you have it not change it. You actually do this all the time. This is something you use frequently. For example, when you're adding fractions that don't have the same base, what do you need? Or same denominator, what do you need? You need a common denominator, right? You need a common denominator to add fractions. So in order to get a common denominator, you don't want to change the overall value. So what would you multiply 2/3 by? No. 7/7. And what would you multiply 2/7 by? 3/3. Sorry, I did that in reverse. The point is you are allowed to do that because what is 3/3? That's 1. And what is 7/7? 1. You're allowed to do that because it is the multiplicative identity. It does not change the value of something. Everybody's surfaces should be flat on their desk. If you add the opposite, so we have inverse properties. Additive inverse of A is negative A, or excuse me, the opposite of A. So if A is negative to begin with, its inverse is going to be what? Positive. So what do you add to -5 to get 0? 5. It's positive to begin with. Why can't A be 0 right here? Why can't A be 0 on that one? Yeah, no 0 in the denominator. Your calculator breaks. Existence ceases to be if you divide by 0. It's not that happy. The only thing I really want you to focus in on so far is what the names of these properties are. You've probably seen and worked with them before, but knowing the word distributive, identity, and inverse, those are 3 important words to know. In terms of what else you see things like this: commutative and associative, commutative and associative. Commutative properties, does it matter what order you add things in? No. It doesn't matter what order you multiply things in. We actually might get to a point in this class where we'll get to see some things where the order of multiplication actually matters. It's pretty cool. There's a field of mathematics. There's a few, but one field in particular, what order you multiply things changes the answer. So there's a field of math where you have this thing, call it A, and you multiply times B. You get a different result if you do B times. It's kind of cool. There's sidedness to multiplication. I mean, you look at these rules, and the reason I bring that up is you might think, like, what's the point? Like, duh, all numbers, when you multiply them, it doesn't matter. Actually, there are certain circumstances where these things aren't true, which is pretty cool. But this shouldn't be too new for you, which leads us to our nice milestone here. Guess what we get to the end of right here at this red line? Chapter 1. That's all of Chapter 1. We've covered all of Chapter 1. Chapter 1, do you remember what we talked about in our last class? You might have watched the video or looked at your notes. We're talking about types of numbers and how to operate with them. That's effectively all of Chapter 1. Types of numbers and how to operate with them. How are people feeling about Chapter 1? For you, it seems pretty straightforward, and it is, but can anybody using a complete sentence tell me what an equation is? Or something you know has to be in it? Or what is an equation? You've used them before many times, Gabby. What's an equation?
Does it have to something?
You got something. There has to be an equal sign in it. It's any expression with an equal sign. Exactly. So you've seen many of them before. For example, a linear equation in one variable. You might have seen something like this, ax plus b equals c, or something like that before. That is an equation because what does it have in it? An equal sign. It's really that simple.
So even like 4 equals 4.
That's an equation. It's two things that are equal. Absolutely. Absolutely. So this is one type of equation. Okay. So there's lots of different things you can do. One of them is solve equations. Solve that one for me as carefully as you can. Solve that for me as carefully as you can. You have a choice. Now, Chris, what do you got?
-3.
Who thinks x should be -3? So you have a friend over there. Some other people you still working on this?
Yeah.
What can you do after you get an answer to see if it maybe is the right answer? You can plug each side, right? So you could check it, right? So one way to check it is to look at the work, but after the work, another way in addition to that is to actually plug it in. 4 times -3 minus 2 times -3 minus 5. You want to know if that's equal to 4 plus 6 times -3 plus 3. -12 plus 6 minus 5. 4 minus 18 plus 3. -6 it's -11 on the left. -14 plus 3. Oh, look, it works. So is this correct? It is. It absolutely is correct. What's the first thing you like? What can someone just tell me, not mathematically what you do, but what's the name for the thing you would do first on these? Combine like terms. Look at each side and try to clean up each side first. I love taking larger math problems and breaking them down into small, manageable pieces, attacking each piece, putting all my focus on a piece, and then having the whole picture come together because I know that each piece has been solidly constructed. 4x minus 2x is?
2x.
2x. So let's do this out. Actually, I'll do this out in blue here. So what do we have here? We have 2x minus 5 is equal. Oh, is there anything we can combine over here?
Yeah.
So 7 plus 6x. Now, we're not quite done. We've combined like terms on each side, but now we need to combine like terms overall. So what operation should I do on both sides? Can someone give me a bid here? What do you want? Yeah, Chris. Take away 2x from both sides, right? So you end up with negative 5 is equal to 7 plus how many x? 4x. Now what? Subtract 7. I like that. So you get negative 12 is equal to 4x. Divide both sides by? Yay. X equals? I just thought of something. You know how when you're dealing with inequalities, if you multiply or divide by a negative number, what do you have to do with the inequality? You have to flip it, right? We should just say whenever you multiply or divide by a negative number, always flip the sign, because what happens when you flip an equation? Nothing. So it still works. So another way to say it, always flip the sign when you multiply it. It doesn't really matter. Are we okay with the math that's on the board right now? Are we okay with it? Decentish? Okay. So they give you lots of steps. The book likes to kind of summarize things. And this is actually not bad. I think they do a pretty good job of picking a good order of things right here. Clear fractions or decimals. Eliminate fractions by multiplying each side by the least common denominator. That's a great thing to do. If you guys don't like seeing complex fractions, what can you multiply by? What's that key thing? What's the best thing to multiply by? It's up there in that first chunk of words. What do you multiply by? Yeah, see this thing right here, the least common denominator? Multiply by the LCD. That's a great thing to do. And eliminate decimals by multiplying by a power of 10. Separate, oh, look at that. Simplify each side separately. And then you isolate the variable that you're trying to solve for. And then what step of these 5 do most people skip, either for time or because they forget to? Yeah, if you have time. Now, it's one of those things, if you were to check every last little answer on everything I gave you, you're not going to have that much time left because we do pretty full examinations. But when you have the ability to and the time, check your answers when you can. It really is helpful. The other thing you can do is there's different degrees of checking your answer. What I mean by that is check your answer to see if it makes any sort of realistic sense. You're not always going to be able to have that as an opportunity, but sometimes. If I have a word problem and the question is like, blah, 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 how much does the movie ticket cost? And your answer is like $6 trillion. Sometimes people write totally absurd answers that they know would be wrong if they actually looked at the realm of what the answer should be. But here are some great steps. So clearing, simplify each side, isolating. How about you try this one for me right here? How about you try this one for me right here?
X equals 4.
Let's see how popular Hannah is today. Raise your hand if you agree. Oh, you're popular today. Nice. Nice. Works out pretty well. Okay, so everybody find a piece of the board. Go up and find a piece of the whiteboard with somebody else. Groups of 2 or 3 is fine. Not the projected space. You can use this space, there. Find some space.
Sorry, David, I was recording the last time.
I played too loud
I mean, 6 over 6 is that.
Which is answer? Yeah. Okay, so x plus 7.
So,
Plus 2x
plus 14.
plus
Did I write down?
4x minus
Yeah, so that's
12x.
over everything.
Alright, so let's start off or no, should we add a no. Do we need to do least common denominator for
Yeah.
6 and 3?
Equals 4.
Because we can just like multiply this by
And then-
we can multiply this by 3.
Is this right?
I think I'm wrong. I think it's my fault. What'd you do first? Okay, it looks like the first step is okay. Although I don't know how you got 4. Oh, it's 14.
Then it's
Easier to do. Yes. No. Oh, wow. What's the So this is which is what the accent
They're gonna be 17.
It doesn't matter. Okay, whatever. 8 times 6.
6 times 8. What's 6
48.
times 8? 8 times 8 is 64. Yeah.
It's 48.
48.
That means that you can use it just as a
Okay, so that goes in there twice. So it's 14x minus 2 equals.
Yeah, I can make the parts.
And then 6 times.
Yeah. What? Yeah, I think we're wrong.
Because you're taking the
They got
long route.
Okay, sure. So you got 2x. So what do you have?
So, wow, we couldn't do that hard.
7.
We subtract.
What do you got? Look at that.
So how many times is so that goes in 3 times? No.
Oh, I see.
20. How do you guys get a 17?
They made a mistake about 17.
They're positive.
Give you a sign mistake.
I gotta make that.
Give you a sign mistake.
What'd you get?
I don't know.
One.
Yeah, same.
Okay.
I don't know.
Okay, they all won. That's
Okay.
2 people.
Okay.
Actually, that's what we did.
Yeah.
This is all right.
Then-
So
Hey, Brad,
Yeah.
almost. They got -1. What'd you guys get? 1.
We got 1.
This is right.
Yeah.
okay.
This is
You got the wrong
Okay,
answer.
right. Okay.
Wait, I want to see you guys right. It's like this side over here.
Okay, sit down. Here we go. Sit down.
Yeah.
Finish it. Sit down.
Still gonna get like.
No, you want it.
Sit. Sit.
What side?
Oh,
East side versus
we're
west
really
side.
generating gang symbols in math. This is good. I like this.
That's the west
This is
side.
the west.
Least intimidating side ever. I see a parody video coming on. Your own version of like Anchorman. That was culturally insensitive. Okay. Anybody see the extended version of that movie? Anchorman 2 on the DVD they released. Anchorman 2. There's like 90 minutes of extended scenes because there's all these scenes where like what's Steve Carell's character's name? Brick. Brick just keeps on talking. It's really funny. It's like about nothing. It's about absolutely nothing. He's amazing. It's amazing. Milk was a poor choice on this day. Okay, so what I really like is that all of you, all of you did great things. Some of you finished it, and some of you went off on a little bit of a challenging direction. One of the hard things with math is that your surfaces have to remain flat on your desk in front of you, but also sometimes you don't know you're doing it the hard way until you're really far into it, and then there's like no turning back. Can somebody tell me what the first step? Look, remember, what's clear fractions or decimals, right? So if we wanted to clear the fractions on this, What should we multiply everything by? 6, because that 6 is the least common denominator, right? What happens, everybody, when you multiply 6 by this fraction right here? Cancels out. But if you multiply one thing by 6, if you multiply by something other than 1, you have to multiply everything. So this gets multiplied by 6, and so does this, right? So you end up with x plus 7, but what happens here? The 2 and the 6 becomes what? So this is 3 times 2x minus 8 equals negative 24. So you have x plus 7 plus 6x minus 24 is equal to... What can I just cancel from both sides? What? What? Wait. Kids. What's 6 divided by 2? 3.
Oh, no, it's not.
You don't need to take any of this down. That's going to be Yes. What? Why?
But why is 2x being multiplied by that?
Because you're multiplying 6 by this.
No, okay.
You do that, all you have to do is change your top number. You don't change the denominator.
Yes, you could, but I'm canceling first. I am simplifying before I multiply, so I multiply by a smaller number. I could, Robert, multiply by 6 first, and then divide it all out by 2. Or I could divide by 2 and then multiply by what's left. 6 divided by 2 is 3. We're multiplying the whole thing, so that's why it's 3 times.
Would it be correct if you
yes, you could
multiply everything by 6
Yes.
and multiply everything by 2?
You're not multiplying by 2, you're dividing by 2.
But though you need to get away the...
Okay, I'll do it the other way. That's exactly what we're doing, Robert. So the other way would be multiplying by 6 to get 12x minus 48 all over 2, right? Robert, look over here.
Yeah.
6 times 2 is 12. 8 times 6 is 48. So do you understand that we've turned this into this right here?
Yeah.
What is 12 divided by 2?
6.
That's 6x minus what? 24. What did we get right here? Okay, so take a look up here. So now, what can I just eliminate from both sides right now? What's on both sides? Yeah, I would. This is what I would do. I would get rid of those. And you have 6x and x. What's 6x and x going to be equal to when you add them together? So you have 7x plus 7 is equal to 0. So 7x is equal to negative 1. Negative 7, sorry. So what does x equal? Negative 1. So negative 1 right over there is correct. So let's find out. Let's find out what happened over here. Let's take a look. Let's see if formulas with percents. Oh, it's exciting. Mathematical models, solving. This is really fun stuff. But let's go back to these two things right here. I gave you an equation in both cases, everybody. I gave you an equation in both cases, and your surface should go back out. What does it mean to solve an equation? What does it mean when I ask you to solve an equation? What does that mean? You just did it properly. What does it mean when I ask you to solve an equation? What?
What does what you're asking for?
What do you mean by that? What I'm asking? I understand what you're saying, but be more specific. Or can you be more specific?
Either to simplify the shortest thing or find the variable that's...
Find the... you're getting really close. It sums up to... Yeah, keep going.
I guess find the x to the variable.
What do you mean the answer to the variable?
Like you said, like...
Find the value.
Find the value that...
corresponds to the variable.
Makes it what?
Happen.
What makes it true?
True, yes. Solving an equation is finding all the values for the variables that make it true. I could say a billion. Is a billion a solution to this? No. No, we found only 4. Yeah, we already solved it. I asked that on purpose. It's only maybe. I mean, that's good if we had solved it. But the idea is, to solve an equation means to find the values that you could substitute in for the variables that make it true. That make it true. So let's keep going here. What other things could we mix in? We could mix in percents. How many of you have worked with percents before? Everybody should raise their hand. You've looked at percents before. It's very nice. But here's the thing. If I gave you an equation, you then have some steps to solve it. Are you always going to have the equation written out real nice and pretty like that? No. Sometimes what are you going to have to do besides put your surface flat on your desk? Sometimes what are you going to have to do? Yeah.
Figure like the word problem.
Yeah, you have to build the equation. You're going to have to build the equation. It's exciting stuff. So, you might get something like this. And we're just
because I know it was the easiest way to make 50 to 100.
Ah, so you just turned it into 100. Are you always going to have a number that's really nicely put into 100? No. So you're going to have what you want over the total. So what goes on top here? 10 liters of acid, and it tells you what's the total volume. 50. So how do you figure out that percent? Well, what's that in decimal? 0.2, and what is that in percent? 20%. Exactly. So if you want to find the percentage something is of something, you need to know how much of the thing you want is there, how much of the thing you want is there, and then you need to know how much of everything is there. How much of everything is there. Does that make sense? Okay, so we're at 20%. That's nice.
What's the easiest way to turn the fraction into a decimal?
Fraction into a decimal. Sometimes when it's nastier fractions, this is one of the things you'll use your calculator for. So for example, let's say I said you had, 10 liters of acid and there were 63 liters total. To find out this, you'd use your calculator. You do 10 divided by 63.
And then
they get the decimal. Yep, you get your decimal. So someone do 10 divided by 6. You could do 10 divided by 63 on your calculator, right? So, you could do it on your calculator, right? You get 10 divided by 63. And you end up with 0.158, right? So you get this. So what percentage would that be? Yeah, it depends on. And hold on. You're getting to a bigger question, which is, okay, so if you did this one right here, that's the decimal equivalent. In this class, unless I tell you otherwise, go to 3 decimal places. Yes. So unless I tell you otherwise, go to 3. So in this case, it would be 15 point what? 873%. Unless I tell you otherwise, go to 3 decimal places. 3, okay? I might tell you round to the nearest percent. If I said round to the nearest percent, you would say 16. But unless I say otherwise, how many decimal places? 3. How do you figure out what the percent markup is? How do you figure it out? Robert.
Well, I got 18%.
Well, again, I'm not asking you what the answer is. Don't know.
I took,
Don't know. Tell me, what'd you do?
I think I put 1200 over 1460, 1464.
So you did 1464 over what? 1200? That's a great thing to do. And what did you get when you did that?
881?
Nope. It should be more than 1. It should be that. Is that fraction greater than or less than 1?
Oh, okay, then I did the opposite.
Okay, you could, but you really got to be careful about it. So you want to know how far a markup goes up, right? So this is going to be an increase. Okay, so if you did this on your calculator, did anybody do that on your calculator right there? What'd you get?
Oh wait, no, I'm sorry, I got
Okay.
I got 1.1.
1 point what? Okay, so again, how many decimal places are you supposed to go to? The calculator, so your calculator, it's exactly 1.22? Oh, nice. Sorry, my mistake. So that means, what is 1.22 in percent? That's under 22%, right? So what's the percent markup? Yep. 22%.
What if you do the other way?
It's wrong.
It's wrong?
You just figured out what the markdown would be. The starting price was 1464 and the new price was 1200. It's not symmetric.
Yeah.
Going down 1464. Let me finish my sentence. If you go down from 1464 to 1200, that is a different percentage than going from 1200 to 1464. Because you got 18, right?
No, I got 80 something.
Oh yeah, but that
I minus
from 100. Yes, but what did you get for final answer?
Like 18.
Exactly. So you got like 18. The answer is going from 1200 to 1464 is a 22% markup. Going from 1464 to 1200 is an 18% markup. They're not symmetric. They're not the same because 1200 is a smaller number than 1464. So if it's asking for the markup, it wants how much more above 100%. If you wanted to get 22% just from the get-go, subtract 1200 from this. What do you get? 264, right? You could just do 264 over 1200, and what would you get? 22. Because what's the markup in dollars? Can someone tell me what the markup in dollars is? 264. So you could just do 264 over 1200, and that would give you straight up 22%. As long as you understand what you're doing, you can come up with the final answer in a couple ways.